I don't say? Okay, yeah. So good afternoon, everyone. So until now, we had really great time, and I hope that and I believe that I learned from the previous presenters, and I hope you will learn a lot from my session as well. So my topic is about machine learning for mobile with MLKit and TensorFlow Lite, and uh, I can see that most of attendees are my students or were previously my students, so I'm really happy about that. But for those of you who don't know me, my name is Johannes Kfle, and I'm academic and research assistant at ASTU. Also, I am a satellite software developer at Space Technology Institute. And you can pretty much get me on the internet with the username Joe Kfle. So if you write me or follow me, I really appreciate that. Okay, so what is machine learning? So is there anyone who have previously worked or know what machine learning is? So it is a very interesting topic, right? So is there anyone who have worked on that previously? So Mac, wait, I'm always have so okay, let's start with what learning is. So this definition is given by economist Herbert Alexander Simon. So it defines learning as a process by which a system improves its performance from experiences. So we humans are a good learner, right? So we learn from our experiences and we try to improve ourselves to make ourselves a better person, right? So we repeat those experiences that give us, good motive or a good experience, and we don't repeat those experiences that give us a bad experience, right? So that makes us a better learner, or so we humans are a good learners. But machines are not designed that way, right? So we give them instruction, and they always try to follow that instruction. And but when we write a code to a computer, they only follow the instruction, right? So they code, and they're not going to make a decision out of that instruction. But it would be a good idea to add a learning feature that means make their own decision based on their experiences. So adding that feature to the machine would be really great idea, right? So they make their own decision based on their experience or based on the data they received previously. So that is basically what machine learning is. And in fact, the other thing that I didn't mention is, always, AI, right? You know what AI is, but artificial intelligence. And so this AI is the big picture, so it's the big circle, and machine learning is a small part of that one. And so why we need machine learning? So this is another question that many people ask or want to know. So machine learning is machine learning can be used to automatically to create a system that can automatically adapt or customize themselves to individual users. So right now we use different kinds of streaming services, right? Like YouTube. YouTube is also a streaming service, or Netflix, or uh, Spotify, or something like that. So they gave us suggestion that based on what we have previously listened or watched, or make a comment, and based on that they give us the videos that we probably we're going to like, or we're going to be interested in. So basically they're using machine learning to make that prediction. And also we use machine learning to make to discover knowledge from large database. So we humans are not good at analyzing large amount of data, so we're not good at that. But if we give them the ability to learn to machines, they are really good at identifying patterns and identifying relationship between large amount of data. So we use machine learning for those kind of problems. And also we use machine learning to mimic and replace certain monotonous tasks which require some intelligence. So I have seen this use case where machine learning is used to identify like illegal items in the security checkup session. So if you go to a security checkup, they will take a picture, and then the machine learning identifies materials that are not allowed to pass through the security check. So humans sometimes may misidentify or just make a false prediction, and so they can make a mistake. So, but if you give them the machines to make a prediction, so they're really good at that. So, and the other thing is why now? So, machine learning is popular now, right? So, why it became popular? So, this is another question as well. So, the first reason is that large amount of data, so flood of available data. So now, in this era, we are creating a large amount of data than ever, right? So, because of internet and everything, we are creating large amount of data. And machine learning like start to shine or works with the large amount of data. So there is a margin that way. So that's why they become popular. And the other reason is increasing computational powers. Uh, Actually, in fact, there was machine learning back in 90s. So they've been using machine learning in 90s, but was not popular like today. The problem is there was no huge amount of computational power, but now we have this huge amount of computational powers in machine learning algorithm works based with high requires large amount of computational power. So that's why they start to shine or got the popularity nowadays. And the other reason is that growing progress in available algorithms, frameworks, and researchers are focusing on developing new algorithms and frameworks, right? So this is basically, there are also another reasons that they become popular, but these are the main ones. Okay, now I'm going to show you a typical workflow of a machine learning project or a machine learning problem. So the first thing that you should do is obviously you try to identify the problem, or you need to have the problem statement. And after that, you gather data for your problem statement. So there are many ways to gather data, or there are many ways to create a data. So I'm going to show you that later. And after you create or collect large amount of data, so as I told you that machine learning requires large amount of data, so you need to gather as much as you can. And so after collecting that one, you don't just give the data to the machine learning algorithm. That you need to massage, you need to split it, and you need to identify that the data are correct for the machine learning algorithm. And after you gather your data, you bring existing model or you create a new model to train your images or train your data onto the machine learning. So after that, you evaluate your model, so how accurate it is or what kind of error it has, and you evaluate that one. So if you don't get the result that you wanted to get, you go back and or choose different model or bring another model or identify or check your data set for errors. And after that, let's say you get the accuracy you wanted to get, and then you deploy that model, and based on that model you make a prediction. So the blue ones are done basically by machine learning experts and probably and data scientists, and the rest is by mobile developer or software developers. So for typical mobile application developer, in fact, there was no way to do a machine learning on mobile devices. And it was hard for mobile developers to add machine learning capability to their application. Right? So until now mobile developer can add a machine learning application to their development without that much knowledge of machine learning. So not dealing with creating model, training model, and different way and those different steps, right? So using MLKit. So this is MLKit is the software development kit for machine learning for mobile devices like Android and iOS devices. So it was brought by Firebase. So you all heard about Firebase. So this was one of their products. So it works well with Android and iOS devices. So what is MLKit? So I told you that it works for both iOS and Android devices, and it is shipped with pre-trained models. That means using this model, you don't need to do this all stuff. So if you got the model, you don't need to gather data for that one. You don't need to train models, evaluate. So don't need to do the what the machine learning expert would probably do. So you just do the prediction and use the model for your purpose, right? So also they support custom models. So if you want to train your own model, or if you want to tackle different areas, so you can also create your own model. So I'm going to show you that as well. Also, you can deploy your model on device. So that means you can ship the model with Android app and put it on Play Store. Also, you can put the model on the cloud and request the processing to be done on the cloud. So in the MLKit, there are different pre-trained models that will come with the SDK. So the first one is text recognition. So with this model, you can do a text recognition, right? So this is a pre-trained model. You can just start using it. So you can recognize texts from images, from labels. So you can do that. You can do that. And the second thing is the face detection. So it's not face recognition, but face detection. So you can detect multiple faces from image. And do other things with that. And the other thing is object detection and tracking. You can detect and track objects. You can do image labeling with this one. So image labeling is in fact to identify objects that are present in the image. So you can do that as well. And the other feature they added is auto image vision age. So you can see the new tag here. So this is a newly added feature. And also you can do a barcode scanning. So in fact there is a library to do that, right? If you previously developed an Android application that used a barcode scanning, you probably used another API. But using this MLKit, you can get pretty much accurate and high performing barcode scanning. Right? So the other thing also you can do is landmark recognition. So you can identify known places using this pre-trained model. So landmarks like this is Eiffel Tower, like Taj Mahal or Statue of Liberty, something like that. So you can identify those places. The other thing is language identification. So you can do on-device installation, translation, smart reply. So this is another newly added feature to the MLKit. So how you get started with the MLKit? So the first thing is you add a Firebase to your application. So probably you know how to add a Firebase to your application. So there are two ways to do that as well. The first one is go to the Firebase console and create a new project and add it to your project. And also, if you are using Android Studio like above version 3.0, you can use a Firebase assistant to integrate your Android your Firebase project to your Android project. So let me show you, and then after that, you add the MLKit dependency to your application. So and then you sync your Gradle, and after that you are good to go to use the MLKit. So let me show you a demo here. So I added the wait. So I added the Firebase to my application, and the next thing that I should do is add the Firebase ML Vision dependency, and then you sync your Gradle. So for this demo, so I'll be doing the face detection. So you've seen what you can do with MLKit, and I'm going to show you how to do the face detection. So let me show you my activity. Alright. So I have a button here. So there is another camera view. So there is a camera view, and also there is a button to take a picture, and from that picture it will draw a rectangle on faces. So I have a camera view and I have a button here. So when the button is clicked, it will take a picture and it will try to run the face detector on that image. So I have face detect. So this is my button. when this button is clicked, these are the methods that are executed, right? So with camera view dot start, so the camera view will start, and camera view dot capture image. So I capture the image, and so on success, that means on if the camera successfully captured the image, these are the methods that will be executed. So first, I will get the bitmap from the camera view. So camera kit image dot get bitmap. So and then I will scale that bitmap, and then I'll run the face detector. So I'll call this method. I pass the bitmap as a parameter, and this is the method actually. So run face detector. So this is the image that you take from the camera view. So the first thing you should do is you create the Firebase Vision image object. So Firebase Vision image. So you create the image from the bitmap you get. So this bitmap is the image that you take from the camera view, and then you create your Firebase Vision face detector option. So these are parameters. So or these are the options you can set it. So Firebase Vision face detector options, and set mode type. For example, I set it to fast mode, or you can set it like accurate. So it gives you like accurate face detection. So these are the options that you can set, and then you create the Firebase Vision detector object. So this is the actual detector that will run on the image. So Firebase Vision detector, face detector. So I create the image, and then I will pass the Firebase Vision image here, so that I create from the bitmap. And then on success, it will return you the face list. So it actually a Firebase Vision face list. So it will return that one. And then you process the result that you get from the detector. I call this process face result method. So this is the method that process the faces that returned from the image. Right. So I said the count 0 to count how many images are. How many faces are in the face. Right. So I made a loop here to loop over. So it will take multiple faces in the image. So you loop over the image, and I draw a rectangular bounding box on the image. All right. So it will count how many faces. So it will toast this count face detected. So let me show you a demo here. So jag kallar för ett egenskaper. So Andy build scar. So already ቅድም ረስ ስላደረኩት እኔ ስልኬ ላይ ያለና እሱን እንዳሳያችሁ። ኦኬ ሶ ባነሳችሁ ችግር የለውማ ችግር የለም። ኦኬ አይ ሆፕ ይሰራል ብዬ አስባለሁ። ኦኬ ኢሜጅ ፎቶን ሮቴት ስላደረኩት ነው እንዴ? ኦኬ ሶ አያችሁት? ሶ ፌስ ያገኘው ቦታ ላይ ሶ ሬክታንጉላር ቦክስ ይሰራል ማለት ነው። So what is that? Okay, so እንዳያችሁት አሁን የተጠቀምነው pre-existing model. So we have used the pre-existing model. So but what if you want to create your own model? So you can do that as well. So you know TensorFlow, right? So so TensorFlow is basically machine learning framework. In fact, TensorFlow is very low-level API. So I mean low-level framework. So there are other frameworks that are built on top of on top of TensorFlow. So I usually prefer those. And also, this framework is not optimized for mobile use. So በዚህ create የተደረገው ሞዴል ስልክ ላይ መጠቀም አንችልም. So for that we use TensorFlow Lite. So this is an optimized version of TensorFlow, and we use this model to deploy it on mobile phones. So let me show you the procedure that you should follow to make your own model. So the first thing you should do is in fact, training a new model can take a long time and requires large amount of data. So if you want to create your model from scratch, you have to gather large amount of data. So as I've told you, it took you long time to train your model and get better accuracy with that. But there is a technique called transfer learning in machine learning. So this is a technique to use a pre-existing model to train to solve another task. So just the two tasks should be similar scope. So we use transfer learning, and with transfer learning you can train your model like in few hours or in few minutes. Also, it doesn't require, you don't have to have large amount of data to do transfer learning. So I'm going to show you how to use transfer learning and create your own model. Alright, so first you gather your data and you choose a pre-existing model, and you train your images on that existing model, and then using that model you optimize for mobile, and then you embed the model into your application or store it in Firebase and use it. So for this demo, I will be creating this app. So how many of you watched this series? So in Silicon Valley. So interesting, not it? Yeah. So in your characters, do you remember this character? Yes. Right? What did he create? What did he create? Hot dog, not hot dog. So let's create that application, right? So to create that, the first thing that I should do is just gather data, right? I should gather the hot dog images. So any hot dog image ላገኝ አልችልም. So the first thing that you should do is you should look for public data sets. And luckily, I got this data set from Kaggle, hot dog, not hot dog image. So it contains around 1,000 hot dog images and 1,000 not hot dog images. So it's around 46 megabytes. So I downloaded this model, and I chose to use the MobileNet pre-existing model. So this is actually a completion, CNN network architecture. So I chose to use this one because it is a similar task that I wanted to perform. So it is a classification application. So also my problem is also a classification application. So I showed this one to train my new images. So there are different versions of MobileNet. So with the image size of 224, there's also with the image size of 120 or something like that. So I created this command variables, right? So and then I use this retrain script. It is Python script. You can see that there are many parameters for the retrain script. So bottleneck, how many training steps. So this is in fact another important parameter for the training purpose. So how many steps that your machine learning is going to learn. So the higher the number, the better the accuracy you will get, but also the more time you will take. So 500 is pretty much good for my use case. So the model directory, the output, so summaries, and image tier. So this is another important parameter that you should pass to for the retrain script, where your data set is located, right? So image tier, data set, hot dog, not hot dog. So in fact, you should care the folder structure to retrain your model. So let me show you that. Okay, so this is my dataset folder. So you have hashtag, not hashtag. So the folder structure should be like this. So in this folder, I have around 500 image of hashtag and another 500 images of not hashtag. So I retrain my model, and then it will output the retrained graph.pb, right? So this is the output of my model after retraining it. And also it will output the retrained label. So this file only contains the labels or the labels of your model. And then after that, you optimize it for mobile users. So that is a TensorFlow model. So you need to optimize it for TensorFlow Lite model, right? So this is the command that you use to optimize or to convert it to TensorFlow Lite model. So you give it the input, the output. So our input is the retrained graph, and our output file is going to be docs optimized graph.tflite. So the output format is tflite. So in the other parameter, you don't need to change them, right? So this will output the docs optimized graph tflite. So this is the optimized model for your application. So and then I found this GitHub project that was trained on mobile. So and then I only changed the I only replaced my model with them. So right, so in the model path I passed the docs optimized graph.tflite. So in fact you should put the optimized model in the asset folder, and then you replace it. I replaced it with mine, and let me show you what I was able to get. Okay. So this is only trained on haddag and not haddag. So it shows that right now it's not haddag, so it is not detecting haddag. So let me. I don't actually. Okay, so. So is it going to detect that? Oh. So can you see that? So it is detecting haddag with 99% accuracy. So this is pretty much, you can easily transfer and learn to tackle any problem, right? So. Okay, wait. So, like once you, let's say, once you ship your application or place it on Play Store, and you change, let's say you change your model, you got the better result or a better accuracy training another model. So what can you do with that? So there are two options, by the way. So the first thing is ship an app update, right? So you publish an update in the Play Store, but people or users are not good at updating their mobile devices. I mean, mobile device applications, right? So what you can do is you can host your model in Firebase, and let's say when the user is connected to Wi-Fi, you can just update the model only. So based on that, you will get a better. You can get they will get an update of your model. And also, you can read more about MLKit on firebase.google.com/docs/MLKit. And also, you can get my slides at speakerdate.com/joke. Right. So if you don't have a question, thank you.